Okay, this is a lesson on using proportions to solve percent problems. So let's start with the problem, what percent? So what percent of 6 is 4? Get my pen going here. All right, so we're going to say, when we use a proportion, we say what percent, we're just going to say x over 100. And equals, and it says what percent of 6, so whenever you see of 6 like that, that's going to mean out of 6, so that's where the going to go in the denominator, and we put the 4 there. So, and I think most of you would recognize that 4/6 is 2/3 or 67, so, but we can go ahead and solve this with cross products, but I think I'm going to simplify first here. So I've got x equals 100 as 2 is to 3. So since there's no obvious multiplier, I'm going to say 3x equals 200, and then I'm going to multiply by 1 over 3 times 1 over 3. And I'll get that x equals 66.6 repeating, and so, and since that's out of 100, we'll say 66.7, or approximately equal to 67.7%. All right, now let's go to the next page. So let's talk about what percent of 5 is 4. So we'll do that same thing. So when I say what percent, I'm again going to say x over 100 as out of 5, and so that's 4. And so, and here I do have a multiplier that's obvious, so, and I think we know this already. So times 20 times 20. So x equals 80, so 80%. Make sure we express it as a percent. All right. Next we'll say a little bit different on this one. What number is 24% of 300? So on this one, when we see the 24%, we're going to say, well, that means 24 out of 100, so that gets us half of our proportion. So 24 out of 100. And then since we say what number is 24% of 300, and again, anytime you say of, think of that as out of, and that becomes the denominator. And so x goes to the numerator. You can see here we have a multiplier by 3. So we get 24, so x is going to end up equaling 72. So this time we're not going to turn it into a percent because it's an amount, so make sure we tend to that detail. I think that's the end of on that page. Go to the next page and talk about 28 is 30%, 35% of what number? All right, so let's start with the 35% on this one and turn that into the first half of our proportion. So we put that there, and since it says 28 of what number, the of what number becomes our variable. 28 would go to the numerator. We don't have an obvious multiplier this time, but we can simplify. So greatest common factor of 35 and 100 is 5, so that'd be 7/20 equals 28 over x. Now we can see our multiplier, which is times 4. So that means that x equals 80, and once again we're finding an amount this time, not a percent. So, and then it's always a good idea to read it back into it and say 28% is 35% of 80. That sounds right, and we'll move on. So on this one, I've got what is 55% of 60. Let me go ahead and make 55% into the first half of our proportion. And since it's of 60, we'll say that's the denominator. We'll put x in the numerator. And again, no clear multipliers, but I have a common factor of 5 again, so I'm going to say 55 divided by 5 is 11, and 100 divided by 5 is 20, and that actually reveals a multiplier. How are you doing? So as we said, we can see our multiplier here of times, you can see a multiplier here of times 3, times 3. So we end up with x equaling 33. And okay, so that's our answer there of 33. Now, so let's slide this up just a little bit. So 36 is 20% of what number? All right, so let's make the 20% the first part of our proportion. Since it's of what number, that's where the variable goes. 30 will go in the numerator. Let's remember that 20 1/100ths is 1/5, and that's 30 is to x. We can see we have a multiplier here of times 30 times 30. So that means that x is 150. Let's see if there's another problem. And okay, next problem on this page is 25 is 25% of what number? So let's turn the 25% into fraction. And since it's of what number, there's x. Let's put the 25, and then we put the 25 in the numerator. Since 25 and 25 are the same number, x has to equal here 100. So that's an easy one. All right, so let's look at 36 is what percent of 24. All right, so now when you see what percent, let's make that x over 100. We see the of 24 here, so it means out of, so that means denominator here. And so this is the first one that's going to exceed 100%. So I can't see my multiplier yet. Let's see if simplifying helps. I have a common factor of 12. And so that's going to be 3/2. We can now see our multiplier of 50. So 3 times 50. So this is the first one to exceed 100%, but that's what the case is in this case. So x equals 150, but we're going to say 150%. So that's, since 36 is bigger than 24, it's more than 100%. Okay, there's nothing else on that page. So let's look at a word problem here. So you have the artist collection of paintings includes 48 portraits. All right. So it's an artist collection, and the paintings includes 48 portraits. The portraits make up 15% of the collection. So how many paintings are in the collection? All right. So what we know here is that, well, first of all, let's get our 15%. Let's express that as a fraction. Now, the 48 is the part of the whole here, so that's going to go numerator, and we can put x as the total. In this case, x is the total number of paintings in the collection. We knew 48 had to go in the numerator because that was a part of the collection. Then it was the 15, it constituted the 15%. So now, from here, we can simplify here, see if that helps us. So that's 3/20 equals 48 over x. We actually can see a multiplier here. Otherwise, you could cross multiply. So that's times 16. So times 16. And we're going to declare our final answer here of x equals 320, I believe. So that's going to be 320 paintings. All right, and so on this one you have a baseball player makes 155 hits, and again I've had to explain this to people who don't know about baseball. Hits is not just hitting the ball, it's actually when you're able to get on base, a single, double, triple, or home run. And he got 155 hits and 570 times at bat, and in one season. And then in the next season, he got 177 hits and 585 at bats. All right, so let me just get this consistent here. So this goes with this. So for both seasons combined, what percent of the times at bat were hits? Okay, so we're combining both seasons in this problem. So we see what percent. That just means x over 100. Now, what we're gonna do on the other side is we're gonna combine. We're gonna have number of hits for one season plus a number of hits for the next season. And we're going to have number of at-bats for one season. So anyways, so you have at-bats, sorry that came off a little. So that's at-bats plus the number of at-bats for the second season. So let's slide up here a little bit, and so let's put those numbers in there. So we have x over 100 equals the number of hits for the first season, which was 155, plus the number of hits for the second season, 177, and then we have the first season, 570, plus 585, all right? And so you end up here with 332 over 1,155, or 1,155, and that is x is to 100, all right? And so then you can cross multiply here. Let's go ahead and do that. So you get 1155x equals 33200, and multiply by 1 over 1155 times 1 over 1155, and we get that x equals so x equals 0. Actually x equals 28.7, and so we'll say, so in baseball we refer to, so the percent would be 28.7 baseball. They actually do it out of 1,000, so 28.7 would be the percentage there. Okay, and that's the end of the lesson.